Hey guys, welcome to my garage. Today I'm going to show you how to verify bad sockets on your pinball machine. Now I've already went through this testing and verified that those sockets were bad. Because they were all not working, I actually assumed that it was another problem, electronic problem. So I went through a whole series of tests to verify the circuits that drive the strobes. These are the strobes. And so I'm going to show you how I did that in case you ever need to do it yourself. So before we get started, I'm going to explain the circuit to you. So here we go. Skip that. I need to go back. I need to go back here to the driver board. Right here. So here's L14. It comes out. The signal comes out pin 22 here, A3J3. Now, so just a little familiarity with schematics here. Help anybody out. So this is saying A3J3. So A3, the first part, is the board or the component. In this case, A3 is the controller board, and then J3 is jack 3 on the controller board. The other side of this that actually has the wires coming off would be A3P3 for plug. But in this case, this is the board schematic, so we don't have wires, we have traces. This is A3J3. We're looking at L14 right here. We see it's pin 22 on jack 3. And I'm not going to worry about, well, I can try to explain a little bit of this as well. So this is a latch flip-flop, which in the configuration it doesn't latch. It latches high. And then whenever signal is applied here from the controller board, it pulls low, which in turn allows a low signal through here. See lamp ground, bam 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 bam. This transistor, where we at? So this transistor here will go low, pin 22 will be low, from there just got a better way of showing this. From there comes to, see here, part of PO, that's part of A through J3 pin 22. This is our L14 signal. That low signal comes through this transistor. You see this, man, this is hard to do, being able to see. Alright, so see, these are grounded here. So this is your ground coming in. Am I on the right one? No. So this is your ground coming in. Once it receives the low signal on the base here, allows the emitter to go low. That's what supplies the ground to your bulb. Okay, this is the hot side. So it's a constant high 24 volts. We're supplying a ground to allow the bulb to illuminate. So on the other side, this is your 24 volts on this side. It's going through this connector, which is 1A13P1. See the P, and see this is the J1. So this is P1. This is the resistor board. Picture of it right here. It has 4 ohm 7 watt wire wound resistors, 4 of them. Supply to this board is 24, well, is 24 volts. I'll show you. All the way up here, see 24 volts DC. I'm telling you right here. So this is 24 volts to illuminate this light. We give it the ground. Now these right here, this is your wire colors. So 855, if you look right here, there's your color codes. 8 is gray, 5 is green. So this is a white wire with a gray and 2 green stripes. Right here. So you can see that's on all these right here. 100. So that's a 1 brown and 2 black stripes. That's how you can find them. So what we are going to do is back over here on the controller board, we're going to insert a test probe here on pin 22. We're going to make sure that we get the negative pulses when the computer tells the strobes to fire. And then we're going to put our test probe here on this emitter of this transistor. Make sure we get negative pulses there when the computer tells the strobes to fire. And then we're going to test exactly right on the socket and look for those negative pulses. Once we confirm those are good, then we're going to check 24 volts DC coming in here, constant. And then we're going to check that we have 24 volts DC constant here at the socket. So first I decided to test the signal coming out of the driver board. This is the driver board. I'm pretty confident the signal coming from the MPU itself is good. I've tested this harness here previously, so I'm sure it's good. So I wanted to check the signal coming out of the driver board, going to tell the lights to activate. So what I'm using, I have a test probe, so this will tell me when I have a low signal. It'll show the pulses. Since we're using TTL signals to drive those lights, this is the best tool I have to test it. The multimeter doesn't refresh fast enough to be able to catch the pulses. So the logic probe, I have getting 5 volts right there, pulling off of the 5 volt supply to the computer. Logic probe has to be on the same power supply as the signals you're going to be testing because of the potential. You want the same potential and timing. Got it grounded right there. And then to tap into the circuit here, I'm just using this little test probe. If I can get it in the view, I'm using this little test probe here. This wire comes with this little kit that I have for prototyping electronics. So I'm not gonna be able to do this and hold the camera at the same time, so I'm gonna get it inserted, and we'll be right back. Okay, got a little test probe into there, pin 22 on the A3J3 connector. Then I have a alligator clip. That's it. Pull that out. Alligator clip going to our logic probe. Now let's give it the beans and see what it does. Alright, so currently, you can see, it's being held high. The signal is being held high, there's no pulsing. So now I'm going to start a game. Look at the pulse. So now we know it's pulsing low, which is telling the strobes to fire, but they do not. Alright, we got the hood up now. next component in the circuit is Q1, which I've marked right here on this driver board. I'm going to connect my alligator clip to the emitter of Q1. Here where you guys can see. So I'm on the emitter now of Q1. And I'm basically just going to do the same test I'm going to do the same test looking for the low pulses on the logic probe. Low pulses are present. So far the circuit is checking out. Alright, now I've connected the test probe to the, I should say, the ground side of the light socket. And again, we'll do the same check. And we have pulses. So we've got the ground signal is making it all the way to the light socket. Next, we're going to have to check the power supply to the light socket. Alright, so on the positive side, the first thing I wanted to do was double check that these wire wound resistors here are good. So I've got a test lead connected to each side of R1 there, which are connected to the basic multimeter. I get this thing to focus. Come on, fella. There we go. Alright, so we want this on resistance. The omega sign there, that's the sign for ohms. That's what you measure resistance in, is ohms. Now, this is supposed to be a 4 ohm resistor. Got about 4.85. And if you're wondering why the difference, that's going to be if I connect the two test leads together. Oops, you couldn't see that. So I tested the test leads together now. I'm getting 1 ohm pretty much. So your test setup will carry some impedance. So account for that. So these resistors are good. Well, this one's good. I already tested the other 3. Testing them's the same. They're all good. Now I wanted to make sure I was getting the 24 volts into this resistor pack. So in order to make sure of that, I've connected my ground to a known good ground here on the lamp driver board, and then the other lead is connected to one side of the resistor. Now I want my multimeter on volts. This is an auto ranging. As you can see, it's on DC volts. Give the machine the beans, and we got about 26 volts, which is close enough to the 24 volts we expected. So we got voltage at least this far. Next, we're going to check it directly at the light socket. So in order to do that, then connect the positive lead of our multimeter to the positive lead of the socket. Turn the machine on, and we've got our 26 volts there as well. So everything checks out. We have the positive voltage getting to the socket, and we have all the negative pulses that the computer commands getting to the socket. So it was at this point that I said, well, we've got some bad socket. I guess they're all bad. So just to double check that, make sure it wasn't the LED bulbs or the LED replacement bulbs we got, I piggyback a light bulb in, and I'll show you that. So this is just a little rig I put together. So I got some wire wrapped around the negative part here. I'm connecting this exactly to the solder point on the socket, and then this side I'll touch to the positive. This side I'll touch to the positive of the bulb, and we'll see if she strobes. So I'm gonna set you down and get you in a position here where you can see. Can you see? Get it set up here. Uh-oh. Come on, fella. Okay. Hold that right there. Don't worry, 24 volts won't hurt me in this current. Can you see? All right. No games. All right, starting game. There she goes. So definitely bad sockets. Alright guys, so that's how I verified that I needed new sockets. Any questions, comments, concerns, be sure to put them in the comments down below. Hit that like button, subscribe. Got a lot to do to this guy, and I think you might want to hang around, might even learn a little something. And remember, if I can do it, you can do it. Thanks for watching.